Okay, kids, it's time to do 10.3, working with the exponent of an exponential expression. So we'll just start with some notes. So big one, let's recall our rules of exponents. And remember, we learned all this back in chapter 6. So first we have a product of powers. A to the m times a to the n is going to be a to the m plus n. Then we have power to a power. A to the m to the n is equal to a to the m times n. Little c. Negative exponent. A to the negative m is going to be 1 over a to the m. And also 1 over a to the negative m equals a to the m. What else? Let's see. We have a product to a power. A times b to the n equals a to the n times b to the n. We have a quotient to a power. A over b to the n equals a to the n over b to the n. And finally, one like this, little f. If I have a to the m divided by n, remember we can write that a couple ways. This is a to the m, then to the 1 over n, or a to the 1 over n to the m. So these were all discussed back in chapter 6 with varying degrees of detail. All right, so that brings us to we're going to jump to some examples. So big 2, some examples. And you might want to open your books to page 212 or 213, that bottom number of your textbook. We'll start with number 4. All right, number 4 says, which is better, an account earning 2% a month or one earning 7% every 3 months? Okay, so which one do you think would be best? So we have to think about this a little bit. Sometimes our units are different, so sometimes it's best to put everything in terms of the same unit. So what unit should we use? Well, I'm thinking if we turn everything into years, it might give us a little better idea of what's going on. Okay, so let's see. Or we can just run through some numbers. All right, so let's see. So let's let t, or let's not do years, let's go by months. So let t be in months. So let's look at the b to the t. So this is, so little 1, the 2% per month. So that means our b value is going to be 1.02. So b to the t is going to be 1.02 to the t. All right. Then if I have 7% every 3 months, all right, what's our b value going to be? That's going to be 1.07, right? But then we have to take into account the 3 months. So our b to the t is actually going to be 1.07 to the t divided by 3 because of the every 3 months. So the idea is once t gets to 3, then I get a 1 in my exponent and I get the full 7%. So then we have to use one of our rules of exponents. Oops, I'm way down here. I'm so sorry. Okay. So here we have our t divided by 3 because it's every 3 months. So we have to divide by 3. So this is 1.07 to the 1/3 to the t. Then 1.07 to the 1/3, we grab our calculators. 1.07 raised to the 1/3 is 1.023 to the t. So when we compare the b values, now everything's in months. So which ones would be better? So it turns out the 7% every 3 months is a little better. So 7% every 3 months is the better option. Okay, so then that's the first example. Now let's do number 26. So let's see. Number 26 says, an exponentially growing population quadruples in 22 years. How long does it take to double? Well, that's interesting. So let's see. So we quadruple in 22 years. All right, and this is population. So if we let initial population, INIT, initial population, if that's going to be denoted with p sub 0, then quadruple would be 4 times p sub 0. So we have 4 times p sub 0 equals the initial quantity times some b to the 22, right? So what we want is, how long will it take to double? So the idea is, this is actually pretty simple. Since it took 22 years to quadruple, it must take half of that to double. So the answer is 11. So 11 years to double. Because the whole idea is, if it takes 11 years to double, then double that gets to 22. So that would be 4 times. So 2 times P0 takes 11 years. And then when we double this, we get 4 times P0. Gives us 22 years. Okay, that's more of a thought problem than anything else. All right, what about number 30? Remember, you can pause this at any time if you want to think a little more. So in number 30, it says the half-life of a substance A is 17 years. The substance B decays at a rate of 30% per decade. Of which substance is there less in the long term? So let's see, A, let's see, 17 years, so half-life. And then substance B, what do we have? All right, so 30% decay per decade. All right, so basically, which decays fastest? Okay. So we got to think, what does half-life mean? So remember, half-life means 50% decay. So substance A decays by 50% in 17 years, and B decays by 30% every 10 years. So we have to think about how this works. So what we can do with this is, we have, so the growth factor here for B is going to be 0.7 per decade. Well, 17 years is 1.7 decades, right? 17 years is 1.7 decades. So we have the substance for B is multiplied by 0.7 to the 1.7 in 17 years, which is 0.54, or 54%. Right? So since I'm being multiplied by this, the growth rate for B is 46% per 17 years. I lost you again, per 17 years. So what does that mean? That means B is going to grow more slowly. So therefore, A decays faster. Okay, so the whole point here was getting the units together and getting the 17 years in. All right, so let's see. So those are a little complicated. You may want to think about those a bit. All right, so now that was little c. Should have been little c. All right, then little d will do 38. All right, let's see. So in 38, we're given v equals 500 times 3 times 2 to the t divided by 5. All right, and we're asked just find a, the growth factor, and the growth rate. All right, so well, this is simple. A is 500. All right, but B is a little more complicated, so we have to do some work. Well, let's look at this 3 times 2 to the t divided by 5. Well, we got to do some work. This is going to be 3 times 2 to the 1/5 to the t. Oh, actually, wait. Oh, I messed this one up. The parentheses threw me off. This is the same thing as 500 times 3 times 2 raised to the t divided by 5. So you get 1500 to t divided by 5. So A is 1500. So the 3 has no bearing here. And our B value is just going to be 2 to the 1/5. And when we plug that in our calculator, what do we get? We get 1.15 if we round to 2 decimal places. All right, so then therefore what's R? So remember, R is going to be 1 minus B, or B minus 1, excuse me. So that's 1.15 minus 1, which is 0.15. So R equals 0.15, or 15% growth. Keep losing y'all today. All right, and we'll do one more. A little E, number 40. Running low on time, so let's see. So V equals 3,000 times 2 to the t over 9 plus 5,000 times 2 to the t over 9. Well, what we need to notice is common factors. So we take that out. 2 to the t divided by 9 times 3,000 plus 5,000. So this is 2 to the t divided by 9 times 8,000. So rearrange terms. 8,000 times 2 to the 1/9 to the t. So we get 8,000 times 2 to the 1/9 is 1.08 to the t. So our A is 8,000. Our B value is 1.08. And R equals 8% growth. Okay? That's all we got for today, so I'll see you guys in class tomorrow.